Good morning, my lovely 12s. Right, buddies, here we go. We're starting a brand new unit of mechanics, and it's a really critical, really important unit, which you will do loads and loads and loads of. If you ever take physics, or if you're taking physics at the moment, you'll already be familiar with lots of this stuff. But yeah, it's a super important unit, and this is kind of tells you, well, it's the basis of physics. It tells you why stuff moves, it tells you why stuff works, and it's called dynamics. So please put the title dynamics into your books for me, please. Cool. Now, pretty much, my buddies, I like to always just put this on so you kind of understand why your course is called mechanics. What we've done so far, when we did SUVAT and when we did constant motion and we did those graphs and stuff, to like the velocity time graphs and the displacement time graphs, all of that stuff was called kinematics, because that was looking at how things move, okay? Now, things don't just move on their own, though. There has to be something that causes something to move, and that's the study that's called dynamics, which we're going to start today. And it's kind of all about forces and accelerations and yeah, things along those lines. And there's so many different forces and stuff as well. I think we only deal with 2 or 3 courses in the entire course here, but if you take physics, you'll know for sure there's like electromagnetic forces, there's gravitational forces, there's like nuclear forces, there's all sorts of forces that exist in real life, but we only just deal with a couple. But anyway, kinematics, like how stuff moves, plus dynamics, why stuff moves, is equal to mechanics. So as we do kinematics and dynamics, you can see why what we're doing right now is called mechanics, and that's why you're in the mechanics module right now. How exciting! But yeah, anyway, it's largely, all of the stuff that we do is largely down to one bloke. Well, he's built upon everything that people did before him, but it's Sir Isaac Newton, who's actually one of yours, an English guy, and yeah, he's kind of the one who started all of this stuff, that really formalized it and developed a lot of the methods that we still use today. So all of the mechanics that we do in this course, and even the mechanics that they used for outer space things, like when the famous one is when they put the person on the moon, they only used Newton's form of mechanics to do that. They didn't need the refinement that came a little bit later on. It was Newton's stuff, which he came up with in 1643 is his like lifetime. So in the 1600s, he came up with all these discoveries. It was enough to put people into space, even though it was way, 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 way back then. So it's quite impressive, and actually it's so impressive, the type of mechanics that we do is actually called Newtonian Mechanics after him. Now, you've heard of this guy too, Einstein. He pretty much revolutionized everything that Sir Isaac Newton did. So what Isaac Newton did didn't work for things that were very fast or things that were very small, like things that are the size of an atom. It didn't started breaking down for, and things that are the size, things that go nearly the speed of light. This stopped working for Newton, and so Einstein has actually got a whole bunch of theories out there that corrected that, and so that's why he's a super famous guy as well, just the same as Sir Isaac Newton is. How exciting! Cool. So anyway, back to what we're actually supposed to learn. The first thing I'm going to show you is what's called free body diagrams and balancing forces. Now, I'm going to make you do all of these things in a really systematic way. I'm going to make you lay them all out in exactly the same way, in the same way that I made you write out the SUVAT givens, because I think that kinematics, what you've just finished, could be rather tricky, but I think that you didn't probably find it very tricky, and it's because you got in a really good pattern. Well, physics, often physics just in general, but like this mechanics stuff for sure, is like that. If you can just kind of have a method, and you can fit your method around things or adjust your method to the question, you're going to be good to go. So I'm going to teach you a really systematic way to make this stuff seem easy to you, but it's a bit tricky. So first things first, forces are just pushes or pulls. You don't need to write any of this down. This is maths after all. It's not physics where you might have to actually explain stuff very much, but I want you to understand, that's all. So what a force is it's just a force is it's just a push or pull on an object, okay? Now we measure it in a unit that's called newtons, and that's because it is Sir Isaac Newton's big breakthroughs and stuff, is all of this amazing dynamic stuff, so they call it newtons in honor of him. Now, people don't really know what units mean often. That's kind of a trouble with a unit. So I always want you to understand. So if I say, oh, that was like a 400 Newton force, I want you to be like, oh, that's big, or oh, that's small. I want you to actually have an idea of that. And so here's a good activity that you should actually do. And I know you probably won't, but I want you to at least think about it and maybe do it if you can just think about it later on when you go down to your kitchen or something. Get just like one of those regular bags of sugar that everybody has in their house, the ones that you use for baking or the ones that you use for coffee and tea and stuff, just a standard old basic bag of sugar, and pick that one up in your hand. They weigh 1 kilogram. So if you pick that one up and put it in your hand and feel the weight of it pushing your hand down, well, that is almost exactly 10 newtons. So if I said to you, is 100 newtons a lot of force? You could say to yourself, well, could I carry 10 bags of sugar? And that kind of gives you an idea. Or if I said if that is 1,000 newtons a lot of force, you'd be like, well, can I carry 100 bags of sugar? And it kind of gives you an idea of what these newtons actually mean. Cool? So just, the physics in me wants to tell you that. But anyway, back to maths. We've got this thing here, okay? This is our first equation that I want you to write down, and there's only going to be a couple, okay? And it's this. It's F net equals ma. Okay, now here's what that means, my buddies. F net is an overall balance of forces. So say that I was pushing against a desk and I was pushing it toward you with 30 newtons, but you were going to push it back toward me with 40 newtons. It means that the overall force is going to be 10 newtons towards me, and it's going to accelerate toward me because you pushed it harder than I did, so it's going to accelerate toward me. That's all that this is really saying, okay? So it's F net equals ma, where F net, and you should write this down, is the overall balance of forces, or what they usually call this is the resultant force, okay? So this is the resultant force, okay? It's like the overall force. Now, it's called F net from kind of, you know what the word net means maybe from business studies and stuff like that. If you made a whole bunch of profit, but then you had to pay a bunch of expenses out, well, when you take your like income, I shouldn't have said profit, when you take your income and take off the expenses, it's kind of like what you net is what's like left over, and that's why it's called F net, is what's left over. It's equal to the mass of the object, and it's going to be times the acceleration, okay? And that's the one formula that I'm going to get you guys to know. So you do have to memorize that one. It's very, very, very important. Now, one other force that we're going to see all the time, because we are on Earth after all, is this guy here. It's a formula for weight, okay? Now, weight, maybe contrary to some people's popular belief, weight is not actually weight is actually a force, okay? It is how hard you're being pulled toward the Earth. It's not like your mass. So if you were to say, I weigh 65 kilograms, that is not your weight, that is your mass, okay? So if you went to the moon, your weight would be less because the moon is smaller, there is less gravitational force, but your mass would be the same unless you lost your arm or something going off on the moon. So yeah, hooray. So this is what we got anyway. This is the weight, which is a force, and it's just going to be equal to your mass. And do you guys remember what g is? Well, yeah, it's the acceleration due to gravity. Due to gravity. Do you remember what the number is? Yeah, 9.8 meters per second squared near the Earth's surface is the acceleration due to gravity. Cool beans, buddies? Okay, sweet. So there's all the basics of it. There's the physics side of it. There's me being really like getting into it just because I like it. But yeah, just I want you to understand the basics of it. F net is an overall force. It's equal to the mass times acceleration. Weight is just how much if you've got anything, I have a weight because I'm a person. A pencil has a weight because it's a thing as well. Like a lamp has a weight. Your computer has a weight. Everything's got a weight that's got a mass. And so this describes that force. It's just the thing's mass times times the acceleration due to gravity. Cool. So are we ready? Here you go. First ever actual dynamics question for us, my buddies. And yeah, it's already kind of laid out for us. So it's got a picture for us already. That picture is actually called a free body diagram. And yeah, I'm not going to worry about that just yet. We'll do free body diagrams in a sec. So here you go. Let's read it. It says, in each of these diagrams, The body is accelerating as shown. Body just means object, okay? So doesn't mean it's a person or anything, it just means it's an object. It's accelerating as shown, so it's accelerating to the right. You always draw acceleration like with an arrow, like that, with a stick with two little arrows on it. Velocity's only got one arrow, we'll talk about that later too. Find the magnitudes of the forces of x and y, magnitude being size. Okay, are you ready, buddies? I'm gonna do A, and then I want you to do B by yourselves after. Here's how it goes. What we've got here is an object, okay? An object that weighs 2 kilograms because they put that in it. Now, what we've got here then is there's a 4 Newton force pulling it left. X is pulling it right. We don't know what X is. Y is pulling it up. We don't know what Y is. And the force that's pulling it down with, I don't like it when the book does this, but they've called it 2G. So instead of actually saying what the force was, they've given it as a multiple of G. That's okay. It's cool. It's 2 times 9.8 if you want an actual number. But yeah, that's 2G going downward, and Y is upward, acceleration to the right. Here's how you're going to do it, my buddies. It wants to know what x and y is. Well, you can do these things amazingly using what's called components. And here we go. This is where I'm going to turn you into my little clones. You have to do this in exactly the same way that I do, over and over and over again. So even if someone gives you a shortcut way, I still need it my way, because my way, my buddies, that I'm going to show you will scheme every single method mark out of every single question. You will be able to get everything completely wrong from start to finish and still get half of the marks on your exam if you just follow my method, and that's why you will. So let's do it. Okay, here's what you do. Let's get x first, okay? And here's what you do. You think to yourself, where's x? Well, is it a horizontal force or is it a vertical force? Well, when you look at the picture, it's a horizontal force. X is fully in the horizontal direction. So here's what you write. You write down hor for horizontal. And you pick a direction that you want to be positive, just like when we did the Suvat equations. Well, it's accelerating to the right, so I'm going to pick right to be positive. That's step one. Step two is this. You're going to write down what's called an F-net equation, okay? A force balance equation. So here's what you write. You write F-net. So the overall balance of forces is going to equal to, and which forces are pointing right? Well, X is. Any forces pointing left? Yep, 4. And because it's going left, I'll put take away 4. Yeah, because right was positive, so a left force is going left. Do I have to do anything with the 2? Well, no, actually, because it's not a force, it's an acceleration. So all we've got in our forces is this. The overall force is going to be x, which is the right force, take away 4, which is the left force. These guys here are vertical, so we'll just bin them off, we'll just ignore them. Okay, now what's F net equal to again? That's right, it's mass times acceleration. So we're going to do this, an inline substitution. We're going to swap F net out for ma. So on the left, I swapped F net for ma. On the right, I still have x take away 4. Okay, more inline substitution, my buddies. This is so important. Don't ever do this calculation separate. Keep it all in line, just like I've done. Look at your question again. Now we have ma equals x take 4. Do we know what m is? Yeah, 2. Do we know what a is? Yeah, it's 2 also. And that's equal to x take 4. So there you go. There's no more marks in this question, so you can go right to the final answer. You can write x equals a right now if you want. I'm going to show an extra step. But look, 1, 2, 3 steps. It'll get you every method mark every time. Just for anyone who's confused, 2 times 2 is 4. X take 4. X then is equal to 8. Pop the unit back in, newtons. Can you see that it came out as positive? That means it's to the right, which is what we said it would be. So that's a result. Cool, so I got x. How do I get y? Well, y is here, up and down. So what do I write? Yeah, you guessed it. Vert! Which way do you want to be positive? It makes no difference because it's not having an acceleration. Let's go up, because why not? We're positive people. Let's go up. Looking ahead, looking up. Okay. What do you do next? Yeah, your F net equation. F net equals, which one was going up? Well, y. And what do we do with that? Well, we take away the downward forces, which is 2g. Does that make sense, my buddies? Good. Okay, now here's the thing. You guys know that F net is equal to ma. Is this thing accelerating vertically? Is it moving up and down? Well, no, because the acceleration is only left to right. which means that A is 0 when F net equals ma. The A is 0. Now if A is 0, it means you're going to times the mass by 0, which means the whole thing's going to be 0. So I like to draw a stick through it and put a 0 straight away when it's not moving, which means 0 equals y take 2, and g is 9.8. Which means y is just 2 times 9.8, which I think is 19.6. Should I confirm that? I think it's 19.6. Yeah, it is, because it's 0.4 less than 20. Yep. So there you go. Bish, bash, bosh. Okay. What I want you to do right now, my buddies, all on your own, all by yourselves, is pause the video and try B. And yeah, go. See if you can do it. Okay, and you're back. So let's have a little check then, buddies. How did you get on? Well, for B, here we go. Don't think I want to answer this one fully, so I'm just going to start it, and I'll let you guys check when I give you the textbook work if you got it right or not, okay? Textbook does it a little bit different way to me, but my way is better. You'll see soon. Okay, here's what you're going to do. Horizontal, and I'm going to pick left as positive because that's the direction acceleration is. You'll do this. You'll go F net equals, well, what's left? Well, 80. What's right? Take x. Cool? F net, it is accelerating, so we'll switch it for ma. And here, watch me skip steps like a champ now. M is 4, and a is 2. So I didn't actually write what F net was ma, I just popped them in. So skipping a step equals 80 take x. Oh, I said I wasn't going to do it, but now it's not a hard one, so I may as well. Okay, so that means that x, my buddies, 4 times 2 is 8. 80 take 8 is 72. X can come to this side. X is 72 newtons, like a boss. Yeah, Cobain's, that's a minimal step, okay? That's a proper skipper that would get you full-on marks still. Okay, you ready? Vert. Pick a direction to be positive. I'm going to go with up because why not? Do you want me to go with down to be different? I'm going to go with down just to be different, even though none of you will have. I'm going to go with down. So here you go. You ready? F net. I've made down positive, so mine's going to be different to yours. I've got 4g going down, plus I have a 20 going down from this little arrow here. Take away my y, and I think that's all I got vertically. Now it's not accelerating up and down because there's no vertical acceleration, only 2 horizontally. Switch that out for 0. 0 equals, and you're going to get 4 times 9.8 plus 20 minus y, which means no more marks anymore. You don't get marks for algebra manipulation. 4 times 9.8 plus 20 all in one go to cheat is 59.2. So y equals 59.2 newtons. Like a boss, buddies. Cool beans, cool beans? Okay, right. Here we go. Starting to get way harder now, so I've jumped right into the deep end. Here we go. These are more fun questions. We've got this. Your 1,500 kilogram car won't start and you need to get it off the road. You push it with an applied force of 400 newtons, but the frictional force resists the motion with 120 newtons. What is the net force applied to the car? What will its acceleration be? How fast will it be going after 3 seconds of pushing? So this is like a triple, like quadruple question. Okay, you ready? Here's how you do every single question. First step first is if you have a highlighter, I've done it for you by doing the colors, but if you had a highlighter, go through and get the numbers so that you're ready to go. Okay, and I would use a highlighter in your tests and everything. You're after the net force to begin with, you're after the acceleration after, and you're after how fast third, okay? So I've sloppied mine up, but if it was just a black and white question, which it will be, it's better to do it this way. Okay, you ready? First step in every single one of these questions, my buddies, is going to be to draw the free body diagram. Now, a free body diagram is just a picture of the situation that only uses rectangles. So you ready? Here we go. It's about a car. So here's our car. It's a rectangle. Okay? It weighs 1,500 kilograms. That goes inside. And that's step 1. Step 2, my buddies, is you whack some forces onto it. You say, what force is the car experiencing? Well, it's being pushed, so it's got this force here, an applied force. I'm going to call it F subscript A for the force applied, and I'm going to call that equal to 400 newtons because it was given in the question. Cool? It says that there's a frictional force. Now, friction forces oppose motion. Yeah, like you know that for sure. So if there's a friction, it's going to slow you down, and it's going to go this way. Now it's a force of friction. I'm going to call it F for the force of friction, and it says it's 120 newtons, like a beast. Cool. Now you might think that that's it, that that's the only two forces, but we're going to go for the vertical ones too. We're going to do this all in one lesson, but it's still cool. Go for the vertical forces. What else has a car feeling? Well, it's got a weight, because everything on Earth has a weight, okay? And it's going to have a weight that acts vertically downwards. So we'll just call that W, and we'll just leave it at that, okay? W for weight. It doesn't get called F, it gets called W for some reason. Now, here's a new force which you've never heard of before. If this was it, if there's just these three forces, which are the ones that people think about, the thing is that the car would actually fly through the road into the middle of the Earth. So there's got to be a force that resists it. There's got to be a force that pops up that stops it going through the Earth, and that's this guy here, which you call R. This is called the normal contact force. People also call it the reaction force, and that's how come I think they call it reaction force, and I think that's why it's called R as well. Whenever there's just, whenever something's touching a surface, it doesn't fly through. And why doesn't it fly through? It's because there's a surface there preventing that. So that's why you've got this normal contact force. Happy days, buddies? Okay, sweet. So let's do it. What's the net force applied to the car? Well, let's do it, my buddies. What's the net force applied to the car? Okay, we're pushing to the right? So what are we going to do? Which direction do we care about? Is there any accelerations? Oh yeah, there is actually. And there's also an acceleration. We'll include that this way. It does accelerate the way you're pushing it. Cool? Bang! Free body diagram all the way done. So here we go, my buddies. To start with, we are going to say, what's the net force applied to the car? Well, let's do it. Horizontal. Because we're pushing it horizontally. The force is going to be horizontal. Pick a direction to be positive. How about right? Because it's accelerating to the right. That's a sensible choice. Cool. What do you write down next? Well, yeah, the F net equation. F net equals, and which forces are right? Well, 400. Which forces are left? Take away 120. Bang. Normally you'd switch F net out for MA, except for they've actually asked for it. They said, what is the F net force? So you ready? F net then equals 400 take 120, which is 280 newtons, like a boss. Happy days, buddies. So actually, that is the answer to the first part of the question. So I'm just going to do it in yellow highlighter, I think. That answers the first part. So hooray, you got it. That's that done. Now, what is the acceleration is the next part. Well, if you want to do the acceleration, let's just keep going, okay? What's F net equal to? Well, F net's equal to MA, right? So MA. What's M? 1500. What's A? We don't know. That's what we want. On the right-hand side, what have we got? The 280. And I don't want the newtons in. I only put it there because it was the answer to the question. There you go. Bish bash bosh. Get A by itself, divide both sides by 1500. 280 divided by 1500 is going to equal 14 over 75, which is 0.187. 0.187. Because we're in standard units, the units is meters per second squared. So hooray, that's the answer to the second part of the question. So result. Cool, we're winning. And the final thing then is how fast will it be going after 3 seconds of pushing? Okay, it's a little bit different here now. So that was like the answer to A, that's like the answer to B, and now if we're going to go to the answer to C, it's a bit harder now. How fast will it be going after 3 seconds of pushing? It's not a question about the forces anymore. This is a question about how it's moving, not why it's moving. It's kinematics. So what do? Well, we do suvat. Pick a direction to be positive, right, because that's the way it's accelerating. Suvat. Just like last time. Do we know how far it goes after it's been pushed? Nope. Do we know its initial speed? Yes, actually, because we're pushing a car that's stationary. What's its initial speed going to be? Well, 0, because it's being pushed because it won't start, so its initial speed 0. Do we know its final speed? Nope, but that's actually what we want. Do we know its acceleration? Yep, 0.187 meters per second squared. And do we know how long? Yep, 3 seconds. So we want the one that hasn't got s in it, which is v equals u plus at. Cool? So V equals 0 plus 9.8 times, yep, sorry, I made a mistake there. I thought I made a mistake there. No, it's not 9.8. I did make a mistake there. That's acceleration due to gravity. That's not the acceleration in this case. A is 0.187, and time is 3 seconds. Cool. Which means V, my buddies, is just times 3 in the calculator is 0.56. It'll be going 0.56 meters per second. Okay. That's an example of a hard-ish but standard-ish one as well. Okie doke, my buddies. Cool. Right. I'm gonna give this a scalp. Am I gonna give this a skip? No, it's quick. I'm worried your video is gonna be too long, but I'll give you extra periods of revision if you need to. Okay, here we go. You ready for the next one? You're sliding a 20-kilogram suitcase on the floor at constant velocity against a frictional force of 15 newtons. What force do you need to apply? Okay, what's step 1? Yep, free body diagram. Draw it. Push pause. Get ahead of me. Okay, sweet. What forces have we got on it? Well, it's being slid along, okay? So I'm going to go with it sliding to the right. I'm going to call that FA for applied force. It doesn't really matter if you don't even put that in there. Oh, and actually, we don't know what that is. That's what we're trying to figure out. So we don't know that one. Cool. It says there's a frictional force this way, which is going to oppose it. So that's going to be FF equaling 15 newtons. Cool. What else are we feeling? Well, it's on the floor, so it's got a, or sorry, it's a thing, so it's got a weight, and it's also got a normal contact force, so it doesn't fly through the floor. And that's it. And the acceleration? Well, no, actually, because it says these words here, constant velocity. That means it doesn't got acceleration, so we don't need to put an A on it, which is cool. If you want to be really sophisticated, here's what you can do. You can say that it's moving by putting a single arrow on a stick and putting a V above it, but that actually won't play a role in our question. It does help though, so yeah, hooray. Cool. What force do you need to apply? Well, look at it. It's in the horizontal. So what do? That's it. Hor! Pick a direction to be positive. Right, because that's the way it is. You'll get the same answer no matter which way you make positive, though. What's next? F-net equation. F-net equals, the force to the right was Fa, take away the force to the left, which is 15. Now, is it accelerating? No. So Ma is going to be 0. So F-net is going to be 0, which means that the applied force is just 15 newtons, like a boss. That one, my buddies, was an easy one, but it was a trick because you had to know that F-net was equal to 0 because there was no acceleration. Cool. Final one. A body of mass 5 kilograms is pulled along a rough horizontal table by a horizontal force of magnitude 20 newtons. There you go. This is an example of some highlighter action. 5 kilograms pulled along a rough, which means it's got friction, horizontal table by a force of magnitude 20 newtons, and against a constant friction force of magnitude 4 newtons. Given that the body is initially at rest, I'm going to go a different color there because I know that that's nothing to do with what's causing the forces. Find the acceleration due to the body to start with. Okay, I think honestly you can do all of these on your own. So what I would suggest now is to pause and get as far as you can. Skip through my explanation until you get stuck, so virtually none of you should be listening to me while I'm actually doing it unless you got stuck. And then when this box disappears, it'll have the questions in it, okay? So check your answer with mine, but pause, go. Okie dokie, and you're back. Let's check it out. Okay, first step then, find the acceleration of the body. I need a free body diagram. So to start with, let's get that going. It's 5 kilograms. What forces has it got? Well, it is it's being pulled along a table with 20 newtons, so that's 20 newtons that way. It's against a constant frictional force of 4 newtons, which is this way. 4 newtons, I'm going to call it, oh, I don't even need to give them names, I'm going to. Fn equals that. Fa is equal to that. It's got other forces too. It's got a weight and it's got a normal contact force up there. There is acceleration, which is going to be that way. 2 sticks to show acceleration. We're after the acceleration. So what do? Well, horizontal. Pick a direction to be positive. Right. the direction of acceleration is always a good way to pick. It makes it easier. You don't get negative numbers then. So here we go. F net is going to equal, the right force is 20, the left force is 4. What's F net equal to? Well, MA. Do I know what M is? Well, yeah, 5. Do I know what A is? Nope, it's what I'm after. 20 take 4 is 16. So A, my buddies, is just 16 divided by 5. 5, which is 3.2, which I should have been able to do mentally. But that's okay. 3.2 meters per second squared. Boosh, as your first answer. B, check out the distance of that the body goes in the first 4 seconds. Well, is it suvat or just giving it away? It is suvat. Yeah, that's it, because it's kinematics. So you ready? Pick a direction to be positive. Right, it can be paused. Suvat. Ooh, I've not left enough room for suvat. Oh dear. Oh dear. I'm going to do suvat up there instead of making it sloppy. Okay, here you go. Suvat. B. Okay, here we go. Okay, what do we know? You know, it starts from rest, it says, so that means U is 0. Do we know S, the distance it goes? Well, no, is what we want though, so put a square on that. V, the final speed. Don't know that. Acceleration, we do know that. 3.2 meters per second squared. Time, yep, we know that too. 4 seconds, it says in the question. Right, so we need the one that doesn't have V in, which is S equals UT plus 1/2 AT squared. So S equals 0, because that's, 0, plus 1/2 3.2 times 4 squared. Bish bash bosh into the calculator. You're going to get 0.5 times 3.2 times 16 equals, and we've got 25.6. 25.6 meters. Like a boss. And the final thing, my buddies, final one's actually easier. Find the magnitude of the normal reaction force between the body and the table. Well, what was the normal reaction force again? I said it's R. With the reaction force is R. So how do we get that? Well, vert. Vert. So back to dynamics. Pick a direction to be positive. Whatever direction you want. Up. You ready? F net is equal to R take W. Cool. Is it accelerating vertically? No, because it stays on the table. It doesn't fly off the table. So 0 equals R take, and our weight isn't actually given, so we're going to have to use the formula. Remember, weight is mg. M, my buddies, is 5. G is 9.8, which means that R, my buddies, is just 5 times 9.8, which is 49 newtons, like a boss. So I hope you're okay on that. I know it's brand new, but I swear you'll be so quick at these, you won't even have to think about them. Once you get the pattern going, you'll be able to decipher these questions and do ones that seem impossible, but you'll just rattle through them. Okay, so here's what I'm going to get you to do. Whole bunch of practice. Page 164, question 3 to 11. I just left 1 and 2 off because I didn't like them because they're about resultant forces, which is a bit weird. 3 to 11 are the ones that are proper questions. So have a go at those, my buddies. When you're all done, attach it onto the Google Classroom for me so I can have a look. And that's it from me. So see you next time. Bye, buddies!